So this is sample problem number 2 for the topic steady electric currents. And we are given a potential difference of 10 volts, which is maintained across the ends of a copper wire 2 meters in length. So this is the copper wire, and if the mean time between collisions is 2.7 times 10 to the negative 14 seconds, so what is the electron mobility mu sub E and the drift velocity v sub d? So to solve that, we have to know these formulas, which we have derived from the previous videos. So for us to solve for the electron mobility, so we're going to use this formula. So the electron mobility is E, which is the charge of the electron. So that would be 1.602 times 10 to the negative 19 coulombs times tau, which is the mean time between collisions. So that would be, that is given to be 2.7 times 10 to the negative 14 seconds. So that is 2.7 times 10 to the negative 14 seconds. So all over the mass of the electron. So that would be 9.109 times 10 to the negative 31 kilograms. So we will be getting an answer of 4.747 times 10 to the negative 3 meters squared per volts second. So if we have to determine the drift velocity, so this quantity, we will be using this equation. So the drift velocity is equal to negative mu sub E times the electric field. So if we are only going to get the magnitude, so that would be mu sub E times the electric field, but we are not given the electric field. But we are given the electric potential, which is 10 volts. So given 10 volts, we can solve for the electric field using this equation. So using this equation, we can first solve for the electric field. So the electric field would be V over D. Therefore, we can substitute that to the original equation. Therefore, the drift velocity is equal to mu sub E multiplied by E, which is V over D. So by substituting the values, so mu sub E, so we already solved that in the previous item, so that would be 4.747 times 10 to the negative 3 meters squared per volt second multiplied by V, which is 10 volts, all over D, which is 2 meters. So we will be getting an answer of 23.74 millimeters per second.